let's take a look at some actual code. So I have kind of this mini program here, and let's just read through this from top to bottom. We'll actually do a couple of examples of these. So the first line, right, int y equal 10. That's just a normal variable declaration. There's nothing really interesting there. And then I have, right, int star space yptr. What this is doing is this is creating a new variable called yptr that is of type integer pointer, right? So before we did things like create variables of type int, type float, type char, whatever, now, right, we have the ability to actually add this little star here, which says make this new variable be a pointer type, right? So integer pointer. The next line is similar. It goes int space star xptr, right? So it's doing something similar, but notice that I have kind of my space in a different place. That you may wonder about. You may think, oh, I wonder if there's a difference between that. For us, there's effectively no difference. Basically, it's a style thing. Depending on what you like, you may want to either put that star with the int or you put it with the xptr. Well, depending on whether or not I have multiple declarations in one line, I'll put the star with the int, because the star to me is a little bit of type information, right? So it's nice to have it there by int, right? That's telling me what exactly I have in that variable, right? So integer pointer, right, to me pops out, right, more than int space star xptr, right? That's kind of, there's a little bit of space, right, between my type information. The caveat being, right, is that if I have multiple things that I want to create, I need to kind of put a star for each of them. Maybe what I'll do is let me just do a quick example here, what I mean by that. Let's say we have, int, this is horrible, int, let's say I want A, B, and C. I'm spacing these out for a reason. Normally, right, if I do this, right, I'm just going to create 3 variables, right, all in one declaration. All these are just normal integers. But then, right, if I wanted to make these be pointers, I have to think about, there should be this star here. But what happens, right, is if I have a line like this, like int star A, comma B, comma C, this means that A will be a pointer, but then B and C will be normal, right? It doesn't kind of carry through, right? That star needs to be with each of the things that you want to be a pointer, right? So if we want B to be a pointer, we need to add a star in front of it too. So if you need to create multiple pointers on the same line, this is the syntax you're gonna have to go through. It's a little bit annoying, but it's the way C works, so we have to deal with it. Okay, so we have those 3 variables initialized, right? 1 normal, 2 pointers. Let's take a look at this stuff now. Now I have this line here, yptr equal and y. Now what this is doing, right, is it's saying that y is going to be equal to, right, the address of y, right? That ampersand y is getting the address of where y is stored, and then that address, that integer, is being stored into yptr. Next line, yptr equal and of y. So again, we're getting that address of y and storing it into xptr. So now both these variables are going to store the address of where y exists in memory. Now, this may seem a little bit odd because of that right-hand side is the same on both sides, but basically what it's saying is that I'm going to have 2 variables, right, both xptr and yptr, that both know about the same variable, right? So that's fine, right? If I have a variable in my system like y, any number of other variables can point to it, right? They all kind of, lead to the same place, right? All roads lead to Rome or something, right? You can have multiple things that all go to the same place. And maybe it gives you something like you can picture like a tree-like structure or something growing out of this. So that's going to be fine. Okay, so going down, I have this here, star yptr equal 20. So that's, right, the dereference star. So basically what it's saying is, okay, I have the value 20, right, on my right-hand side, and I'm going to assign that into star yptr. Well, star yptr will have the effect of going to the address that yptr knows about and looking up the space in memory that it's referring to, right? Because that thing has an address in it, and the star takes an address and actually goes to the specific space. So this line here will basically have the effect of going to that y and storing the value 20 into that variable. Next line, star xptr equal 30. So this again, right, is the same kind of overall mechanic. We're saying equal 30, right? So taking that value of 30 and assigning it somewhere. Well, this time it's being assigned into star xptr, and star xptr, right? That's just kind of another name, right, for y, right? Both these pointers, right? We're pointing at the same piece of data. Those stars get us, from just looking at an address to looking at a space, right? And that's where that 20 and that's where that 30 can be stored. So maybe think for a second. What exactly is going to be the value of y at the end, right? So imagine you're at this final part here. What is y going to be equal to? Well, in the end, right, it'll be equal to 30, right? Because that first kind of line here, right, yptr equal 20, right, that initially sets that 10 to 20. Then xptr, it's the line after it, right? So then it goes to that same variable and replaces that 20 with a 30. So in the end, we have y equal 30. All right, let's take a look at a slightly more complicated example. So in this code, we're going to take a look at the program and trace it line by line and see what exactly happens to the variables that are being defined here. So the first thing I have, right, is just a declaration to say, okay, create x and create y, right? So x is a normal variable, y is a pointer type variable. And then up here, right, we're going to say, okay, initially x is going to be equal to 0, address of x is 2000, address of y is 2004. It should be fine. Okay, so now let's try actually assimilating this thing and see how the pointers are behaving. So over here we go y equal ampersand of x. So what does that do? Well, over here, right, the value of x isn't changing, right? I don't have x equal anything, right? I don't have anything that points at x changing it either. So that'll be kind of, it's just initial value x. Initial value is 0. Okay, and then we have over here, right, y equal address of x. Well, that means I need to think about where is x being stored. Well, x is stored at address 2000, so that's what I would write here, right? Y 2000, right? So I haven't changed the value of x, I've just changed the value of y because that's what I did the assignment into. So we should be good to go there. Next what we have is this line over here that goes star y equals star y plus 10. Now this looks a little bit different than the code we've seen before, but it's very much typical for dealing with pointers. Basically what it's saying is on the right hand side, do star y, and star y on the right hand side is basically saying read something, right? So it's going to go look at what y is pointing at, which in this case is x, take out that value, right? So right now x is 0 in there, so basically this becomes 0 plus 10, right? So you read from an address that was stored inside of y. So you have now 10 on the right hand side, and then that 10 on the right hand side, right? That then is stored into the thing that y knows about, right? Y is an address of something. That star is looking at that position where y is, right? And then our bit of data, right, flows into that address, right? This is y here, right, is whatever is stored at address, 2000. So now over here, right, our x is now actually going to be 10 because we've gone indirectly via y and we've put that value there. Now the address stored in y, that gets, just left alone because we haven't done any assignments to y itself. Last thing we have here is a y++, and this will be a little bit weird. So y++, right, we're leaving alone x, so this time we can kind of leave the 10 here. But then y++, what will that do? What happens, right, is that y is going to change its address inside, right? So what I'm going to actually write here is 2004, right, because x is an integer, right? Y is a point of integers. Integers take 4 bytes, right? And so if I want to kind of step forward by 1, right? Y is presumably pointing in memory at some specific integer. What if I want to look at the next integer, right? That's what that plus plus is doing. It's moving the address forward by 1, right? The size of one integer. And so that means I have to add 4 to the address, right? Assuming that the address is in bytes. So all of a sudden, Y is now a pointer to that position 2004. And then that position 2004, that I really don't know, what's going on. I can't actually change, well, I can change what's being stored there, but it'd be a bad idea, right? That's somehow now looking at another variable, right, another place in memory that I really don't know about, right? So that's a potential bad thing. If I asked you, what was the value being stored at Y's address at this point in time, you really couldn't say anything, right? You just say that is, unknown, right? I don't know what's stored at position 2004. Well, actually, I take that back. The address of y is 2004. So if I do that y++, y will basically have its own address stored inside of itself, which is kind of weird, but that's what happens in this case. So on to our third example. In this example, we're actually going to introduce what's called a double pointer. You guys may remember this from, for example, an exercise or homework or something. Basically, the idea is this. If I have variables that can store addresses of other variables, well, doesn't that mean I can have sort of a second variable that stores the address of a variable that stores an address? Well, yeah, you can do that, right? Pointers can point at pointers, can point at pointers, can point at pointers, right? Here, though, we'll just do kind of a double pointer, which is typically what you'll see. People don't go too crazy with doing, a 6-level deep pointer. Generally, it's either a normal pointer, right, or a double pointer. So let's take a look. Here, right, we start with kind of our original variable, which is I, right? I is storing 137. Then we create a second pointer called J, well, a first pointer called J, and then a second pointer called K, right? And notice that these are kind of labeled, right? J is a pointer, K is a pointer to a pointer. All right, so let's say we try to simulate this, right? This line is pretty straightforward. First thing that we have to think about is this J equal and of I. So what does that do? Basically what happens, right, is if we do that assignment, we are going to go and look at the address of where Y is and store it into J. on my screen here, the notation I'm using is basically to say that that number right next to the box, right, this 100, 160, right, let's assume those, right, are the addresses of where things are stored, right? So 100, right, is the address of I. Therefore, right, that j variable, the j variable stored at location 160, that will now contain 100, right? So I have next to each box, right, the boxes basically representing, right, memory that I have that I can store something into. Right, I have the address of it, and then I have the variable, right, that requested, right, or is assigned to that specific space in memory. So the first line, right, means that j stores the value 100, which corresponds to the address where I is storing stuff. So not too bad. Now what happens, right, is that we can have kind of another level here, right, where we go k equal and of j, right? So all of a sudden, k, right, is the address of j, where j was already the address of I. So in this case, right, that 160, right, that represents the address of where j is, that gets stored inside of k, right? So now k knows about the address where another address is stored, right? So there's two levels in direction getting from k over to I now. So the way we maybe think about this is that outer variable k, right, that's, a pointer to a pointer. If we do something like star k, that star k is basically another name, right, an alias for j, right? It moves you kind of, each star, right, moves you kind of one set of addresses forward, right? You're not all the way to I yet, right? But you've basically gone to that kind of that first step right along that first arrow, and now, right, you're looking at that 100. So that star k gets you kind of halfway, right? Gets you just to j. And if we did another star, right, that second star basically is doing a second lookup, right? So we looked up whatever is in 160, we got 100. Then, right, that second star will say, okay, I'm looking at 100, look up what's there. It ends up being 137, right? So that star k ends up being, returning or evaluating our value stored at I, which is 137, right? So we kind of have these different hops, right, where every star, right, is following the address, the address is stored in the variable by one, hop each time, right? So each star gets us the first star gets us right from 160, second star gets us from 100, right? So that, generally speaking, right, that number of stars, that's going to match the number of ampersands, right? Because you're going back and forth. As an additional thought, it doesn't make all that much sense to do something like k equal and I. Because that k equal and I, well, basically, your and I, that part is fine because that's saying, okay, I is a variable. I'll look up the address where it is, right? But that address where it is, right, is just kind of a computed value. It doesn't really live anywhere, right? We should be looking up the address of where things are stored, but ampersand I, right, that evaluates just a value that's maybe, just out there, right, in a register or something like that. And so it doesn't make sense to do an and symbol on that, right? Because how would we look up the location memory where that thing is being stored, right? It's not going to last very long. Really what we want to do, right, is we only want to use the and symbol next to variables because variables, right, are actually named things that have to exist somewhere in memory, right? So that's when we want to use it. Using them, nested is a bad idea. The stars, though, right, stars we can put side by side because we're just kind of going and following, this path of addresses that's defined somewhere.